Okay, thank you. Hi, everyone. My name is Ying Tong, and I'm an engineer at the Electric Coin Company. So I work on the Zcash project, and that's a privacy-preserving cryptocurrency that uses zero-knowledge proofs under the hood. But this talk today is not about that. This talk is about the Intelligent Cooperation Technology Tree. So what you see here is the working prototype of a technology tree that we've built to map out the applications and the core technologies, as well as the frontiers and challenges in the field of intelligent cooperation. And personally, I was interested in joining this project because I get really heads down as an engineer, and then I get curious about how my work relates to other people's work. And I found this tech tree to be helpful in quite a few ways, which I will demo here. So the top level view of the tech tree is these 7 nodes. And these show the most high level dependency graph that I could think of that connects different subfields in intelligent cooperation. And each of these nodes, as you saw previously, are compound nodes, which means that they contain child nodes that can also connect with each other. But the top level view for me is where we can express the highest level theses about the field, and where we can get really conceptual. So last night at 3 a.m., because I'm jet lagged, I was going through other people's talks today, and then I thought it would be fun to categorize them into these notes. So if I missed out your talk, I'm sorry. It's probably because I didn't understand it from the slides. So yeah, artificial intelligence is probably one of the most well-known, one of the oldest fields. Yeah, we'll be seeing these talks today about artificial intelligence. And then artificial intelligence is a dependency for decentralized artificial intelligence, which is really more of a frontier technology. I think someone will talk about challenges on the path to decentralized AI. And we see tools such as federated learning, differential privacy, fully homomorphic encryption, multi-party computation, and very recently, zero-knowledge machine learning. And then artificial intelligence is also a dependency for private artificial intelligence. Oh, sorry. I think what I just described just now was private artificial intelligence that conceals either the input or the model or both. And this allows people to perform computations on sensitive and confidential data. And so private artificial intelligence relies on private computation, and this is the field in which I work. So zero-knowledge proofs are one example of a primitive that allows us to encode arbitrary relations in some kind of cryptographic statement that can be proven without revealing the confidential information. So we have quite a few talks about this today. And a private computation is also a dependency. It's also a dependency of private decentralized computation. And I think there's a cool project here, Penumbra, that does private decentralized exchanges. And that's an example of private decentralized computation. And finally, decentralized consensus systems, otherwise known as one popular iteration of this is blockchains. And we have a few people working on that today as well. So yeah, at 3 a.m. I definitely found the tech tree very useful in just relating today's talks to each other. So another tool that I use in this tech tree, and by the way, we built this graphing tool in-house, is tags. So If someone is new to the field and they're interested, for example, in the frontier technologies, the high impact areas where there are unsolved problems, they can look specifically for those nodes. And the same goes for applications, core technologies, and risk areas. Yeah. And how I think of these different tags or different categories is that core technologies are primitives, they are mathematical or scientific discoveries, and they unlock new classes of applications. So applications are closer to the user and they address actual needs in the realm of intelligent cooperation. And core technologies and applications are what we need to get to the frontier technologies and to actually progress to the cutting edge of a field. And the frontier technologies are, I think, what's most interesting to someone new to the field, to see where the open problems are. But frontier technologies are often blocked by challenges and risks that can present obstructions to their development. So that's how I've classified all the nodes in the tag tree. So the last sort of useful thing that's come out of this tag tree for me is that I've actually sort of formed new theses, or I've made discoveries about how these areas relate to each other. So I work more in the blockchain space or the cryptography space and less in artificial intelligence. But in the process of building out this tree, it actually appeared like that there were common dependencies and common blockers in both fields that linked both fields together. So one example here is data governance. Data availability is a hugely important primitive in blockchains. Like it underlies, basically, is the underlying assumption, a security assumption for every decentralized consensus system. And in decentralized artificial intelligence, this is also the case. As data sets get bigger and bigger, we need to be able to combine data sets from multiple parties, and we need to be able to also decentralize the ownership of this data in a way that's still secure. So that's one thing that became clear to me by just looking at this tag tree. So some examples of data governance are common data formats, or which make different systems interoperable, data availability or decentralized storage, as well as scalability, how to make your data accessible to even resource-constrained clients. Another one of these connections that became clear to me is that privacy is intimately related to decentralization, in the sense that for any decentralized application to be meaningful, it needs to be private. So, for example, for voting to be meaningful, we need anti-collusion. And anti-collusion depends on plausible deniability. So, and that needs some degree of privacy. For example, in decentralized finance, it's true that we can achieve censorship resistance, but we cannot protect your transaction from being front run or back run or sandwiched or any such thing by the privileged actors, which are minors. So in order to have fairness in decentralized finance, we need to be able to obscure some information about your transaction. And the last example is censorship-resistant social media. So basically, we need to be able to participate in social media like in a truly anonymous or pseudonymous way, so that we are not penalized and censored based on like aspects of our real-world identity. So yeah, this also became clear to me in the process of building this tree. The last trend I noticed was that there are common challenges that are shared across many of these fields. So one of which is security. I don't need to convince anyone of the abundance of security flaws in the blockchain or smart contract world. It also exists in cryptography and many zero-knowledge proof systems. These are not high assurance systems, and we find bugs very frequently as well. And artificial intelligence as well, there's like adversarial attacks, there's all kinds of security concerns, not to mention ethical concerns. Another common challenge is spam prevention or Sybil resistance. In other words, garbage in, garbage out. This is a problem both in inputting data to AI models as well as, for example, creating like multiple identities on the blockchain to like spam votes and to impersonate like end parties. So yeah, I think that was all I had. These are other ways the tech tree has been useful to me. If you want to contribute, the tech tree lives at this on the Foresight website. And if you go there, you can actually interact with the page and create new nodes and connections and delete nodes and submit the changes to us. Yeah, but we're still building out the pipeline for contributions. So yeah. Thank you. Yeah, thank you.